The larynx, trachea, bronchi, and lungs appear in the embryo during the 4th week of development. Let us look at a sagittal section of a 4-week-old embryo, which depicts the pharyngeal region and the embryonic germ layers. The pharynx is located at the cranial part of the foregut, and the respiratory diverticulum develops from a midline groove in the floor of the primordial pharynx. In this transverse section of the embryo, note that the pharyngeal arches are numbered 1 to 6. The 5th arch is usually absent or rudimentary. The caudal part of the hypopharyngeal eminence contributes to the formation of the epiglottis. The endodermal pharyngeal pouches are located between the pharyngeal arches, and the laryngotracheal groove is distal to the 4th arch. Observe the foramen cecum in the floor of the primordial pharynx. The laryngotracheal groove evaginates ventral to the foregut and forms the laryngotracheal or respiratory diverticulum. The laryngeal inlet is located between the arytenoid swellings and behind the epiglottis. The next few sequences of animations take us through the formation of the epiglottis and larynx over several weeks into the fetal period. The laryngotracheal groove gives rise to the respiratory diverticulum, which is surrounded by splanchnic mesoderm. As the diverticulum extends caudally, 2 longitudinal ridges are formed from the surrounding mesenchyme. The transverse cross-sections show how the tracheoesophageal folds fuse to form the tracheoesophageal septum. This septum separates the ventral respiratory diverticulum, tracheal bud, from the dorsal esophagus. The respiratory diverticulum branches into 2 primary bronchial or lung buds. By the 5th week, 3 buds are formed on the right lung and 2 on the left. These are known as lobar bronchi because each goes to a lobe of the lung, 3 on the right for the upper, middle, and lower lobes, and 2 on the left for the upper and lower lobes. By the 6th week, there are 10 tertiary branches on the right side and 9 on the left. Each supplies an area of the lung known as a bronchopulmonary segment. The bronchial tree for each lung branches and extends laterally into the pericardio-peritoneal canal. The splanchnic mesoderm surrounding the bronchial tree will form the cartilage, muscle, and connective tissue that are present in the respiratory passages. The splanchnic mesoderm also forms the visceral pleura, or inner layer, that covers the surface of the lung. The outer wall of the pericardio-peritoneal canal is formed by somatic mesoderm and becomes the parietal pleura. The space between the parietal and visceral pleurae is the pleural cavity. Development of the respiratory passages is divided into 4 stages or periods. The non-functional pseudoglandular period is followed by the canalicular period. The lumina of bronchi and terminal bronchioles become larger, and blood vessel formation increases. Type 2 pneumocytes produce pulmonary surfactant by 22 weeks. During the terminal saccule period, gas exchange across the blood-air barrier may permit survival of the fetus. Finally, there is the alveolar period, during which the lungs become functional. The alveolar sacs are lined with a thin squamous epithelial layer, blood vessels are abundant, and pulmonary vascular resistance decreases.